in my experience, I feel as if high school students, and not just high school students, some university students, they don't actually understand what the real importance of calculus is. So I want you to come from this from a blank slate. For now, forget everything you know about calculus. The biggest danger to approach a subject like calculus is to think about it as a set of rules that you just memorize, and you just apply them to a bunch of examples. If that's how you've been approaching calculus so far, well, it's not the right way, to tell you the truth. It's not even funny that that's just how basic the concept of calculus is. The design and use of calculus is such a creative process, and to just bundle it into a set of rules is a shame for the subject. So calculus is actually an abbreviation for something called infinitesimal calculus. And I know that doesn't reel off the tongue so nicely, infinitesimal calculus. So they shortened it to calculus. Now, we have many branches in mathematics, right? Many different subject areas. Calculus is just one of them. But each one of these subject areas is keyed into a single big idea. Take geometry, for example. Geometry is about the subject of structure of shapes and objects. Algebra is the study of relationships and their relationships with one another. And probability is about chance. So each subject of mathematics has a specific big idea. So what about calculus? Well, calculus is the study of change. Okay? Calculus was developed independently by two famous mathematicians. And there's actually a huge argument in the academic world about who invented it. You know, mathematics is never invented. It's actually there in nature. It's mathematics that happens here on this planet happens on Mars or Pluto or Neptune. Mathematics doesn't change. The physics that we apply to it is different, of course. The gravity on Mars is different from the gravity on Earth. But the underlying equations we use to solve such problems remain the same. Now, this is probably one of the most interesting cases, at least for me. Remember how I said calculus is the rate of change? Well, we could use that in biology. We can use the study of the rate of change of a population over a given time, for example. Right? Exponential is a directly or inverse directionally proportional graph of growth. Population is an example of growth. And if I want to know what the timing of the population is at a specific point, I would draw my tangent line and calculate the exact population at a specific time. But it goes even further than that. Biology, we can study the rate of change over time of a population, or the rate of change of bacteria cells die when inserting an antibiotic. And if done correctly and in an intelligent way, mathematical modeling can predict exactly how much medicine is required to kill a specific virus or bacteria in a specific amount of time.